This is a question from AQA A-level Chemistry. It is a paper 3 question based on the required practical assessments, and this is based on RPA10. I'm going to recommend you pause, have a go at each section for yourself first, and then review. So here is part A. And here we've got parts B and C. So now you've had a chance to go through that for yourself, let's take a look at some of the answers. And you can see that here the question is about ketones. We've got solution X reacting with liquid ketones to form a crystalline solid. The reaction can be used to identify a ketone if the crystalline solid is separated, purified by recrystallization, and the melting point determined. Describe how the crystalline solid is separated and purified. Really common on RPA10 questions. You need to have that really intrinsic knowledge of the methodology step by step. What do you do and why do you do it? So in this case, describing how the crystalline solid is separated and purified. Well, first of all, we are going to filter or we are going to decant. Filtering is probably the preferred option, and that is going to then allow us to take the crystalline solid that we have and dissolve it, but we're going to dissolve in the minimum volume. Now we want to do it in the minimum volume because that means we're definitely going to not have too much when it comes to the volumetric flask. It gives us enough water that we can do washings, etc. later on. So it's a really important consideration to include. The solvent is hot and we are doing that to maximize the solubility of it. So we're going to get more dissolved. We get a saturated solution. And then we're going to cool it. And we cool so that it will recrystallize. Those crystals will form, and once the crystals are formed, we filter it, but we filter under reduced pressure. And when we talk about reduced pressure, you're thinking about the conical flask with the side arm. We're thinking about the specific piece of apparatus, the Buchner funnel and Buchner flask, that will allow us to quickly filter. The under reduced pressure, I cannot overemphasize how important that is. We're then going to wash with cold solvent. We don't want to use a lot of solvent and we don't want it warm because actually that might redissolve some of the crystals. And then we're going to dry it. And we've now got our dry, pure sample of the crystalline solid. Okay, let's move on and look at parts B and C. For B, propanone reacts with the weak acid HCN to form a hydroxynitrile. The hydroxynitrile is usually made by a reaction of propanone with KCN, followed by dilute acid instead of with HCN. State the hazard associated with the use of KCN. Suggest a reason other than safety why KCN is used instead of HCN. Well, it is toxic. Cyanide ions are toxic, and KCN fully dissociates in solution, whereas HCN will only partially dissociate. So we're getting a lot less CN minus ions there. That makes it safer. It helps us deal with the toxicity. Why is KCN used? It's also because HCN is a weak acid and therefore it doesn't fully dissociate. Therefore, it's not going to react as effectively. And then finally, outline the mechanism for the reaction of propanone with KCN followed by dilute acid. Well, let's start by drawing out the propanone, and then we are thinking about our nucleophile. Now, please be careful with these. You're told we're reacting with KCN, that's the reagent, but the nucleophile is the CN minus ion. It must have the charge, it must have the lone pair. And if you include the K, you are going to lose the marks for this. Now that lone pair is going to attack the delta positive carbon, delta positive because of the difference in electronegativity with the oxygen. And the next step here is that the double bond partially breaks. So we show the electrons moving from the double bond towards the O. That takes us to the intermediate, and the intermediate you can see very clearly that we have simply added the CN on in the right place. My C double bond O is now single bond O. That O is now negative because the electrons have moved towards it and it has the lone pair. Every single part of that is vital. Also, do be mindful that the bonds go from the right place to the right place. The bond must go from the C to the C in CN and the C in the CH3. Now from there, second step, we're going to add an H+. This H+ is going to act as an acid. It is going to be attacked by the O, by the lone pair on the O, and we end up, not that you get marks for this, but with the product that we see here. That takes us to the end of this question. Thank you for listening, and goodbye.